This is Populations and Resources Lesson 1.4 Activity 2. You should have just watched the video about how scientists sample jelly populations in oceans. So the ecologists in the video discussed that it's often impossible to count all of the organisms in a population. So instead, ecologists collect samples to provide an accurate picture of how the population is really changing. Some samples do a better job of representing the population, the whole entire population, than others. So a sample is a small part that is meant to show what the whole looks like. So an example is if I give you guys a survey and I have one. It's just the seventh grade. So I give all the seventh graders a survey. We might use those results to represent the population of all middle school students. So it's one small sample, and we can use that to represent the entire population. We could say population is all middle school students in Spanaway, or we could say all middle school students in the world. But either way, a sample is a smaller part that is meant to represent the whole. So we need to evaluate evidence because we can't collect every single jellyfish in the ocean. We can only collect samples and use that sample as a representation of all the jellyfish. So we need to see, okay, well, what kind of samples are good samples? Which ones could actually represent the population? Because some samples are better than other samples. So our criterion for this union is going to be that samples that represent as much of the whole as possible provide stronger evidence. So if we have pieces of evidence and one of them represents more of a whole than the other, we'll consider that as stronger evidence. So today, we're going to practice using the evidence criterion to evaluate evidence that like ecologists do. So even though we have heard that Glacier Sea moon jelly population is increasing in size, evaluating evidence will help us to be more sure about that claim and also help us to learn more about how population changed over time. So what we're going to do is we're going to look at a piece of evidence, and this is moon jelly evidence A. So each evidence card you're going to look at shows a map of a location where jellies are being counted. So you should pay careful attention to the map to evaluate whether this sample represents the entire population. So in this evidence card, the jellies are being counted from this one location. So this is telling us that every year between 1980 and 2010, ecologists counted moon jellies in Glacier Sea, and they counted them from this one location. All this blue is Glacier Sea, but they counted moon jellies at this one location every year from 1980 to 2010. So remember, ecologists cannot count all the organisms in a population. They cannot count all the jellyfish, the moon jellies, in this Glacier Sea. They just can't do it. So instead, the moon jellies in the Glacier Sea population were counted each year in a particular area over 30 years. So this data is used to make an estimate of how the population is changing. So this graph over here shows how the population is changing based on them collecting moon jellies every year for 30 years. And in evidence A, they're collecting every year in this one location for 30 years, and then this is how the population is changing. So what you're going to do is you are going to evaluate evidence A and evidence B. So you're going to go to lesson 1.4 activity 2, and you're going to look at evidence A and you're going to look at evidence B, and you're going to write down anything you notice. So you do that by pressing this plus sign and you enter an annotation. So like, for example, here I would write only collecting in one location, because I think that's important. And then, or Or I might add another one and to the graph and say, looks like a slight increase over the 30 years, but not a drastic change. So that's kind of how I want you to do that for moon jelly evidence A and then moon jelly evidence B. So go to Amplify, go to lesson 1.4, activity 2, and remember, we're trying to evaluate evidence that represent as much of the whole as possible and that those provide stronger evidence. So you should be thinking about which one of these two cards provides a sample that represents as much of the whole as possible. So go to 1.4 activity 2, annotate the cards. You're just writing down what you see, what you notice. Pause the video, and then after you're done completing this activity in Amplify, come back and press play on the video. So now that you have annotated the evidence cards and looked at the evidence cards, we're going to talk about them. So you should see that on Moon Jelly evidence card B, that it represents the whole population because samples were collected at a greater number of locations. So every year there's samples collected in all these places on evidence card B, and in evidence card A it's only collected in one place. So that'd be like if I was in class and I wanted to get your guys' opinion as a teacher about the class or something that we should do, and I asked one person what they thought. So that one person's opinion or what their feedback is how I make my decision. Well, that doesn't seem very fair because then if I asked, half the class, I'd probably get a completely different answer and I'd get an idea of what the class would like as a whole. So that's like this in this case. There's more samples being taken in different locations. So this represents more of the whole population of moon jellies because there's a bunch of different locations that moon jellies are being collected at. So, the graphs show the estimates of the moon jelly population size changed based on the samples. And the graphs are not the same because the samples are not the same. So evidence card A's graph looks different than evidence card B's graph, and that's because they're not the same samples. So the graph from moon jelly evidence card B provides a more accurate estimate of the change in the jelly population because this sample represents more of the whole. It's a better representation of the whole Glacier Sea than evidence card A. So this graph, we would say, is a stronger graph. It provides a more accurate estimate. So if we take a look at the graph a little bigger so you can see it better, we can see that it's not really changing from 1980 up to about 2000. The population stayed relatively stable. It did not change before 2000, but then after 2000, the population has increased. So now that we know more about how the jelly population size changed, we will need to make a model to show how our thinking about births and deaths, births are compared to deaths in the moon jelly population when it was stable and when it was increasing. So in other words, how do the births and deaths compare here when it's stable, not changing very much? And how does it compare here, the births compared to the deaths here, when it is changing? And so that's what we're going to do in the next activity. Make sure that you have pressed hand in lesson 1.4 activity 2 after you annotate the cards.